All right, number 6, guys. So just like question 2 and a few other problems, some of these questions are actually really lengthy to solve, especially on a calculator. So I've pretty much summarized everything in a neat way, which can help you show you the steps you should take to solve every problem. So let's have a look at number 6. So a group of climbers collected information about the height above sea levels, h meters, and the air temperature T degrees Celsius at the same time at 8 different points on the same mountain. So it said 8 different points, so straight away the n value here, the sample size is 8. Okay. Now the data are summarized below. So the sum of the heights was this, the sum of the temperature was that, and then you got the sum of TH and T squared. They also want us in part A to show that that STH and STT are given as shown. Now this is just straight up simple formulas. You should be familiar with the SXY and SXX or SYY formulas. It's just the sum of the variables TH minus the sum of each one T and the sum of H over the sample size. In this case, the different points. So just plug in the values you see. Sum of TH is given here. Sum of T is 61 and sum of H is 6,370. Just smash in the calculator as you see fit and you should get the same results. Same with STT, you get the same results. And yeah, for STT, you're going to use ST squared because imagine this as TT. For the top here, it will be the sum of T times the sum of T or the sum of T all squared, but do it like this so you don't confuse the two notations over N as well. And again, same result. Now, let's move on to the next bit. So the product moment correlation coefficient, so this is the R value in the S1 notation, for these data is minus 0.985, so it's practically close to -1, almost perfectly negative correlated. State given a reason whether or not this value supports the use of a regression equation to predict the air temperature at different heights. So the answer would immediately be yes, only because when you use a regression equation, it measures how close the data points fit on a straight line. And because if you get either +1 or -1 regression, what that tells you is that the data is either perfectly or positively or negatively correlated. So you want to be on that line. So you want to be as close as possible to plus or -1. So yes. And my reasoning here is that R is close to -1, which indicates an almost perfectly negative linear correlation between the temperature variable, the air temperature, and the height above sea level. So yes. So yeah, as long as it's very clear that you stay as close to 1, plus minus 1, then you're fine. So let's go into C, guys. All right, part C. Find the equation of the regression line of T on H, giving your answer in the form T equals A plus BH. And here we have to get the value of your coefficients with 3 significant figures. Now these coefficients are your A and B, so that's what we need to find. And this is easy. To find the value of A, you just have to literally rearrange this regression line to make A the subject, and then flip this A and H with bars. And just to know what the bars are again, the T bar, for example, means the sample mean of T. So it's the sum of T over the sample size, which is 8. And the same thing for H. H bar is just the sum of H over 8 as well. Now, to work out B, and this is the part where you're literally going to be thinking about this for a while, is it going to be SHH or STT? Well, one little tip. This question is worth 7 marks, so it definitely can't be STT, or else you would have solved this question in literally like a minute or so. Secondly, the reason why it's SHH is because it's always, if you worked with X and Y, it's always B would always equal SXY over SXX. And in this case, looking at the equation, the Y variable is T and the X variable is H. Hence why it has to be SHH to make up the marks. Now to work out SHH, the only way to possibly do it is to relate the R value, the correlation value, with all 3 S values. Since you're given already 2 of them, and you're also given R value, which is over here, so that's actually useful. You just have to make SHH the subject. So what I did, I just moved it around until I made it look a bit like this. Okay, just simple rearranging. And then just plug in every single value carefully in calculator all at once to get a result something like this. So about 1.3 million. So if you guys get something similar, let me know. I'll try and post your values here because I'm doing this all repeatedly just to make sure the values are correct. Okay, and I've been using sources online like student forums, so thanks to you guys over there. So yeah, always share your results and let the community know. Now once you find SHH, plug it back into the formula for B which is here, and of course STH, which is also given, to get this answer, the b value, and round it to 3 distinct figures. So you should get something like minus 0.0126. And then using that b value, plug into the a equation and use t bar, which I've already given here, and h bar, plug it all at once, and you should get an a value of 17.7. And that's it. That's literally all you have to do for C. And it's worth a lot of marks. So this is something that you want to make sure you're bagging, especially. And if you're not sure, sometimes even under exam pressure, you might think STT. If you did do it, you would realize that you'll get kind of a ridiculous answer. So that alone can help you like think about which is the best choice. But anyway, let's move on to D. So D. So give an interpretation of your value of A. So A is the 17.7. So looking back here, this is the A. So what that really tells us, and I put over here, that A represents the initial air temperature and of 17.7 degrees Celsius at sea level. So i.e. when 0 meters above sea level. So what that means is that you got to assume that H is 0. So this is literally the intercept on a graph. If you picture it like this, you're going to see that 17.7 is a y-intercept, and it has a negative gradient, so it's decreasing over time. So this means that initially it has a temperature of 17.7, but as you go above sea level, the temperature slowly decreases to a certain point. So that's what it's trying to say. Now E. Oh yeah, so one of the climbers has just stopped for a short break before climbing the next 150 meters. Okay. Estimate the drop in temperature over this 150 meter climb. So this wants you to find the change in temperature. So all you literally do is firstly put the value of 150 into the calculator and then see what that gives you. So T equals 17.7 minus that variable times H, and you should get 15.81. So this is the new time. So you can see it's dropped to somewhere around here, 15.81 degrees. All they want to calculate is the change, the drop. So the drop is just the original temperature at 17.7 and 15.81, and that should give you a drop of roughly 1.89 degrees or 1.9 degrees Celsius. And that's it, guys. That's literally it for question 6. If this has helped you, give me a like, share with your friends. Otherwise, I shall see you guys in the next video.